In this module, you will learn about the topic Construction of a Quadrilateral. We know that a triangle have 3 sides and 3 angles, and to construct a triangle, we require at least 3 measurements, including sides and angles of a triangle. Now, do you think 4 measurements would be sufficient to draw a unique 4-sided closed figure, namely a quadrilateral? No. As different quadrilaterals can be identified on the basis of their properties of sides, diagonals, and angles. Quadrilaterals are made up of 10 parts. However, to construct them, we do not need to know the measurement of all of them. In case of special quadrilaterals like the rectangle, just 2 measurements, the lengths of its adjacent sides, are enough to construct. Now let us learn how to construct a unique quadrilateral when following measurements are given, one by one. Let us first learn to construct a quadrilateral when the length of its 4 sides and 1 diagonal are given. Construct a quadrilateral EFGH, where EF is equal to 4 centimeters, FG is equal to 7 centimeters, GH 5 centimeters, EH 5.5 centimeters, and EG is equal to 8 centimeters. Let us draw the quadrilateral step by step. Step 1. Let us first draw a triangle EFG using SSS construction condition. Draw a line segment EG equal to 8 centimeter with E as center and radii 4 centimeters and G as center and radii as 7 centimeter. Draw arcs to cut each other at F. Now join EF and GF. Step 2. Now we have to locate the 4th point H. This H would be on the side opposite to F with reference to EG. For that, we have 2 measurements. H is 5.5 centimeters away from E and 5 centimeters from G. So, with E as center, draw an arc of radius 5.5 centimeter and G as center, draw an arc of radius 5 centimeter such that they intersect at a point. Step 3. We know that H would be the point of intersection of the 2 arcs, as H should lie on both the arcs drawn. So mark it as H and join EH and GH to form a quadrilateral. Hence, EFGH is the required quadrilateral. Let us learn how to construct a unique quadrilateral when its 3 sides and 2 diagonal are known. Construct a quadrilateral PQRS such that sides QR is equal to 3.5 centimeter, PS is equal to 4.5 centimeter, RS is equal to 4 centimeter, and the diagonals PR is equal to 4.5 centimeter and QS equal to 6 centimeter. We saw that when 4 sides and a diagonal were given, we first drew a triangle with the available data and then tried to locate the 4th point. The same technique is used here also. Let us now construct it step by step. Step 1. Draw a triangle PRS using SSS construction. Now we need to locate Q at a distance of 3.5 centimeter from R and 6 centimeter from S. Step 2. Draw an arc of radius 6 centimeter with S as center. We would get Q somewhere on the drawn arc. Step 3. Now draw an arc of radius 3.5 centimeter with R as center. we would get Q somewhere on this drawn arc also. Step 4. Now Q is the point of intersection of two arcs since Q lies on both the arcs. So mark their intersection as Q and join PQ and RQ to complete it as PQRS. Hence, PQRS is the required quadrilateral. Let us now learn how to construct a unique quadrilateral when its two adjacent sides and three angles are known. Given, to construct a quadrilateral MNOP, where sides MN is equal to 6 cm, MP is equal to 3 cm, angle M is equal to 80 degree, angle N is equal to 65 degree, and angle P is equal to 120 degree. Step 1. Draw a line segment MN is equal to 6 cm using a ruler. Step 2. Now draw angle M is equal to 80 degree with the help of the protractor. Step 3. Cut an arc on this line with M as center and radius 3 cm and mark the point as P, as we know MP is equal to 3 cm. Step 4. At N, draw an angle of 65 degree with the help of the protractor. Step 5. At P, draw an angle of 120 degree with the help of a protractor. Step 6. Now join the arms of these angles to meet at O. Hence, we get the required quadrilateral MNOP. Let us now learn how to construct a quadrilateral when its three sides and two included angles are known. To construct a quadrilateral EFGH, where sides EF is equal to 4 cm, FG is equal to 5 cm, GH is equal to 6.5 cm, and angle F is equal to 105 degree, and angle G is equal to 80 degree. Step 1. Draw a line segment FG equal to 5 cm using a ruler. Now draw angle F equal to 105 degree with the help of the protractor. Step 2. Cut an arc on this line with F as center and radius 4 cm. Mark the intersecting point as E. Step 3. At G, draw an angle of 80 degree with the help of the protractor. Now cut an arc on this line with G as center and radius 6.5 cm. Mark the intersecting point as H. Join EH and complete the quadrilateral EFGH. Hence, EFGH is the required quadrilateral. Till now we have seen constructing a quadrilateral using 5.
Welcome to the session. Today I'll help you with the following question. The question says, construct the following quadrilateral DEAR, where DE is 4 cm, EA is 5 cm, AR is 4.5 cm, angle E is 60 degrees and angle A is 90 degrees. Now before drawing the actual figure, first let's see the rough sketch of this quadrilateral. This is DEAR, where DE is 4 cm, EA is 5 cm, AR is 4.5 cm, angle E is 60 degrees and angle A is 90 degrees. Now let's move on to the solution. Now we'll draw the figure step by step. Now visualizing the rough sketch of the quadrilateral DEAR, we can say that our first step can be draw a line segment EA equal to 5 centimeters. So we have taken a line segment EA equal to 5 centimeters. Now as you can see in the figure, angle E is 60 degrees and angle A is 90 degrees. So next step can be make angles of 60 degree and 90 degrees at E and A respectively. So we have made angle of 60 degrees at E and angle of 90 degrees at A. Now our next step would be to locate the point R where AR is 4.5 centimeters. To do this, what we do is, with A as the center, and radius 4.5 centimeters, we make an arc on the ray AX. So we have made an arc of radius 4.5 centimeters on the ray AX. Now let's mark this point as R. AR is 4.5 centimeters. Now our next step is to locate the point D where DE is 4 centimeters. So we can write, with E as the center and radius 4 centimeters, mark an arc on the ray EY. So as you can see, we have made an arc of radius 4 centimeters on the ray EY. Now let's mark this point as D. Now in the next step, we will join the points D and R in order to obtain the required quadrilateral. So lastly, we join the points D and R so as to get the required quadrilateral DEAR. On joining the points D and R, we get the quadrilateral DEAR with DE 4 centimeters, EA 5 centimeters, AR 4.5 centimeters, angle E 60 degrees and angle A 90 degrees. So hope you enjoyed the session. Have a good day.
Let's see how to get a quadrilateral ABCD. With the given measurements, AB is equal to 5 centimeter, BC is equal to 3 centimeter, CD is equal to 6 centimeter, DA is equal to 4 centimeter, and AC, the diagonal, is 6.5 centimeter. First of all, you must have a basic idea, that is, a quadrilateral is the combination of a pair of triangles. If you know how to get a triangle with the 3 given sides, it is very simple. Let's see here. It is a quadrilateral ABCD. It is a triangle with ACD and another triangle, that is ABC. So the combination of these two is a quadrilateral. Let's see how to get the first triangle, that is ACD, with the given measurements. Now let's draw the side AC 6 and 6.5 centimeter. Mark and name the side AC 6.5 centimeter. Now to get the side CD, take the compass and set the radius 6 centimeter. With center C, draw an arc, and with center A 4 centimeter radius, draw another arc to cut the first arc at a point D. So the intersection point is D. Name it as D. So one triangle is completed. That is ADC. It is not a new topic. We got this already in 7th class. How to get the triangles with 3 different measures, that is a square and triangle. So one part is completed out of quadrilateral 4 centimeter and 6 centimeter. Let's see the second part. If you feel inconvenient in drawing the triangle downwards, you can inverse the paper to your convenient. Now AB is 5 centimeter. Set the radius 5 centimeter again. 5. So draw an arc downwards because you get another triangle downwards. Next, CB or BC same. So BC is 3 centimeter. I take the radius 3 centimeter. With center C, cut this arc. So we got the point B. Now join the sides AB and BC. So totally it is a quadrilateral. Mark the measurement to 3 centimeter, 5 centimeter. So your quadrilateral with all 5 sides is completed, which is a part 1.
Here's another type of quadrilateral. Let's name it ABCD. In this quadrilateral, both pairs of opposite sides are parallel. The first pair of opposite sides is AB and DC. We can see that AB is parallel to DC. We use 2 arrows in the same direction to show that the sides are parallel. The second pair of opposite sides is AD and BC. We can also see that AD is parallel to BC. So we draw arrows like this. Such quadrilaterals are called parallelograms. Both pairs of opposite sides are parallel. This was the basic property of a parallelogram. In a parallelogram, the opposite sides are also equal. This side will be equal to this side. We can say that AB is equal to DC. This side will be equal to this side. AD is equal to BC. And guess what? In a parallelogram, the opposite angles are also equal. Opposite angles are angles which do not have a common side. This angle will be equal to this angle. Angle DAB is equal to angle DCB. And this angle will be equal to this angle. Angle ABC is equal to angle ADC. Remember, this is the basic property of a parallelogram. The opposite sides as well as the opposite angles are equal. Let's see a special case of a parallelogram. In this parallelogram, all the sides are equal to each other. This is a rhombus. So a rhombus is a parallelogram with all its sides equal. It will have all the properties of a parallelogram as well as this additional property that all its sides will be equal. There is another special case of a parallelogram. Let me draw it on a new page. Remember, the opposite sides have to be parallel. It is a quadrilateral drawn like this. The opposite sides of this quadrilateral are parallel, so it is a parallelogram. Let's name the quadrilateral ABCD. Why is it special? All the angles in the quadrilaterals are right angles. This special case of parallelogram is called a rectangle. This is how a rectangle can be defined. It is a parallelogram with all angles being right angles. Just like in a parallelogram, the opposite sides of a rectangle are equal. This side will be equal to this side, and this side will be equal to this one. Now it gets even more interesting. This quadrilateral is a special case of a rectangle. Let's call it PQRS. Like the rectangle, all its angles are right angles, but it has an additional property. All its sides are equal to each other. This type of quadrilateral is called a square. Basically, it is a rectangle with all its sides equal. The rectangle is the special case of the parallelogram, and this square is a special case of a rectangle. But wait, in a square, the opposite sides are parallel, so it is a parallelogram. All its sides are also equal, so it's also a rhombus. Again, what is a rhombus? It is a quadrilateral with all its sides equal and opposite sides parallel to each other. But how is the square different from a normal rhombus? It is a rhombus in which all angles are right angles. Next, we will review all the types of quadrilaterals and how they are related to each other.
Today, let's construct rhombus where a side and a diagonal is known, which is KLM1, where KL is equal to 5 cm, KM is equal to 7 cm. We know the rhombus is a polygon where all sides are equal. Here we have a side and a diagonal. That is KL is 5 and KM is equal to 7.5. So it has all sides are equal. So I am marking the opposite sides, and that means all sides are equal, that is 5 cm each. Now let's complete the first triangle since we have 5 measurements of the quadrilateral, where KL is equal to 5 cm and with center L, radius 5 cm, I am drawing an arc. Now with center K, radius 7.5 cm, drawing another arc to cut each other at M. Join LM and KM and also mark the measurements along the sides drawn, that is 5 cm and 7.5 cm. Now with center K, radius 5 cm one arc, and M also 5 cm radius an arc. They cut each other at a point N. Join NM and KN. The required rhombus is formed with 5 cm side and the diagonal 7.5. Tomorrow, let's construct a rhombus where the diagonals are known. We know the diagonal property of rhombus, they bisect each other at right angles. Thank you.
Today, let's draw a parallelogram PQRS, where PQ is equal to 4 cm, QR is equal to 4.5 cm, and PR is equal to 6 cm. But we know we want 5 independent measurements to construct any quadrilateral. But here you have only 3. So recall the properties of a parallelogram. Let's see the rough figure. We know in the parallelogram the opposite sides are equal. We have PQ in the question, so SR is also equal to 4 centimeter. And also we have QR in the question, so PS is also same 4.5. So we have 5 measurements indirectly you have to think of. The same way how we construct the quadrilateral, you have to construct either PQR triangle first and later on the second triangle by taking PQ as base, or you can take the diagonal as base and construct the top triangle first and the down triangle later. That's your choice. Here I take the PQ as base and complete this triangle first, and on the diagonal I go for the second triangle to complete the parallelogram. Let's see how to do it. First take PQ as base, that is 4 centimeter. PQ, now take the compass and measure 4.5, that is QR, with scale 4.5 centimeter radius. QR is 4.5, so with center Q I am going to draw an arc which is 4.5. Now with center P we have to go for this diagonal which is a part of the first triangle, 6 centimeter. Now measure 6 centimeter radius. Now with center P cut the first arc, so you got the point R. Complete the first triangle by joining QR and PR. We got the first triangle. Mark the measurements, that is 4.5 and 6 centimeter. Now on this diagonal you have to construct this second triangle with sides 4 and 4.5. Again take the compass. Now I am going to construct this 4 centimeter. So I have to set the radius 4 centimeter. With center R, draw an arc with 4 centimeter. 4 centimeter. With center P, 4.5. 4.5 centimeter. So the intersection point gives rise the point S. Now join PS and the side SR. Mark the measurements, 4 centimeter, 4.5 centimeter. So your parallelogram is completed with the base 4 centimeter. I said already you can take the diagonal also as a base to complete the parallelogram. Let's see the second type in our next video. Thank you for watching.